This one symbol sits inside almost every calculation that keeps the power grid alive, and for centuries it was considered impossible. J, the square root of -1, a number that, by every rule you were taught, cannot exist. Today, I want to show you not just what it is, but why it may be the most beautiful idea in all of engineering. Stay with me. It is simpler and stranger than you think. Let us start as simply as we possibly can. Forget the symbol for now. Every number you have ever used lives on a single line. Picture it as a straight road. Your house is 0. Walk to the right and you are gaining. 3 steps right, you have 3. Walk to the left and you are owing. 3 steps left, you owe 3. Every number is really a place on this road, an amount, pointing in a direction. Now, the first beautiful idea. On this road, multiplying is not just arithmetic. It is an instruction. It tells you where to move. Multiply by 2, and you double your distance from home. Stand at 3 times 2, and you stride out to 6. So far, nothing surprising. But one number gives a very strange instruction, -1. Stand at 3, multiply by -1, and you land on -3. The same distance from home, but the opposite side. Now, watch the whole road as it happens. Every point on the right swings over to the left. The entire road has spun, half a turn, right around your house. And that is the secret. Multiplying by -1 was never about making things negative. It is a rotation, 180 degrees. Hold on to that idea, because now something breaks, taking a square root. The square root of 9 is 3, because 3 times 3 is 9. Easy. But now, the square root of -1. What number times itself gives -1? Try a positive number. It stays positive. Try a negative number. 2 half turns and it swings right back to positive. Every single number on the road refuses. For hundreds of years, mathematicians reached this exact wall and simply stopped. Impossible, they said. But you already know something it took them ages to see. Times itself means do the same instruction twice. So the square root of -1 is really asking a different question. What instruction, done twice, makes a half turn? And said like that, you can answer it yourself. A quarter turn. Turn 90 degrees, then 90 again, and you have turned a full 180. So stand at 1 and make that quarter turn. You do not slide along the road. You lift off it entirely. 1 step up into the open space above your house. That spot, 1 single step off the road, is the number we call J. And check it, the way we have checked everything. Do the quarter turn twice, and you come back down, landing on -1. J times J is -1. The impossible number was never impossible. It was just standing in a direction nobody thought to look. And that is almost exactly how it was found. In the 1500s, in Italy, a mathematician named Bombelli was solving an ordinary equation. He knew the answer was a plain, honest whole number. But halfway through, the method forced him to take the square root of a negative. The impossible thing. So he did something bold. He pretended. He said, let me just suppose this number exists and carry it along like any other. And a few steps later, all the impossible pieces canceled, and out came the correct answer. A number that could not exist had walked straight through his calculation and quietly handed him the truth. Others were so unsettled, they called it imaginary as an insult, and the name stuck. One quick note before we go on. In pure mathematics, this number is written with the letter I, but in electrical engineering, I already stands for current. So, to keep the two apart, engineers simply write J instead. Same number, different letter. Now, here is the real question. Why would an engineer ever care about a number that turns? So, why would an engineer ever care about a number that turns? Because the world is full of things that turn. Come to a fair and watch a Ferris wheel. Follow just one cabin as it goes around. Its height rises, slows at the top, falls, and climbs again. Plot that height over time and you get a wave. A smooth, perfect sine. But notice something. To say exactly where that cabin is, its height alone is not enough. You need two numbers. And here is where everything connects. Remember the road and the single step upward where J lives. That flat plane is exactly the space the wheel turns in. To pin the cabin, you give two numbers. How far along the road it sits, that is its shadow, the cosine. And how far up, in the J direction, that is its height, the sine. Put them together, and the whole turning cabin becomes one single number. Cosine plus J times sine. Its length is how strong the wave is. Its angle is its timing. A wave is no longer a wiggly curve. It is one arrow, one number, written with J. Now, watch what that unlocks. On a real power grid, every wave, your fridge, a motor, a charger, becomes one of these arrows. One clean number, written with J. But a grid has thousands of them, all slightly out of step, and the engineer has to add them all together. With the old wave mathematics, adding even two was a page of triangles. A whole grid was practically hopeless. Until 1893, when Charles Steinmetz saw the trick. Do not add the waves, add the arrows. Because adding two arrows is simply placing them tip to tail, and that is nothing more than adding their two numbers. This arrow plus this arrow gives one new arrow. That is the answer. A full page of triangles collapses into a single line of addition that a student could do in seconds. That is the whole secret. J had quietly turned an impossible wave problem into simple arithmetic. Sit with that for just a second. The number they had mocked as impossible turned out to be the one thing that made the entire electrical grid solvable. And Steinmetz's trick is still exactly how every power grid, every transformer, and every electric motor on Earth is designed today. Your phone does the very same thing, thousands of times a second. A number that was one small step off the road, a single quarter turn, quietly runs the modern world. That is J. Not imaginary at all. If this finally made it click for you, I would genuinely love it if you liked the video, subscribed so you never miss the next one, and shared it with someone who would feel the same wonder. Thank you so much for watching.